Hey guys, it's Mrs. Bunker. I thought I would make a video of the notes since I'm going to be out today and I didn't want to lose a day. So if you guys go to Classroom, you should have already answered the lesson for bell ringer, what factors divide the ocean into distinct marine life zones. If you didn't yesterday, you should do that today. So today we're going to take a look at the ocean zones. If you go ahead now and open up the slideshow at the very top of your page, that says ocean zones. We're going to start with that. So the first slide here you'll see says animals and plants can be classified into three major groups. So we have three scientific terms that we're going to put on here. The first one is plankton. These are going to be all the organisms that are floating at or near the surface. So they're not able to swim on their own. They're just kind of floating in the water and moving by the water movement, the water moving them through. So these are organisms that float at or near the ocean surface. There are two types we're going to talk about. The first is called phytoplankton, and I know some of the classes yesterday mentioned this. These are going to be organisms that are doing photosynthesis at the surface. So they can do photosynthesis. The second type is called zooplankton. And if you take a look at the beginning part of this word is zoo, right? What would you typically find at a zoo? Animals. So these are going to be small animal-like plankton or larvae of other organisms that aren't able to swim on their own yet. So small animals and or larvae. So a couple of examples of this are called diatoms. We also have what's called dinoflagellates. And jellyfish actually are considered to be plankton as well. So we're going to put down these as examples, and then we will look at the pictures of them and learn a little bit more about them later. The second group is called nekton. These are organisms that can swim on their own. So these are animals that can swim with their own power. So all the fish, whales, sharks, turtles, squid, all of that would be considered nekton. So fish, we'll put down whales, turtles as a couple examples. And then the last group is called benthos, and these are organisms that live on the ocean floor. So animals that live on the ocean floor, such as starfish, clams, lobster, coral. These would all be considered benthic organisms, which is a variation of the word benthos. Okay. On the second slide, you have listed here several factors are used to divide the ocean into distinct marine life zones. So you probably put down one of these three. We're going to put down three factors. The first is the availability of light. If you're at the surface, you're going to have sunlight. If you're deeper in the ocean, no sunlight. I think we've talked about that a few times now. We have terms for those zones, which we're going to put on the next slide. The next one is distance from shore. So as you're moving out from the beach area, we can divide the ocean into zones, and we'll add those. We'll see those in a diagram on slide 4 here in a minute as well. The last one is water depth. So as you go down in the ocean, we can divide, based on depth, the ocean into layers, and then we would find different organisms living at the different layers, and we would have different pressure and temperature, like we talked about yesterday, would vary as well. Okay, so let's go to the next slide and talk about availability of light. So you can see here in the diagram, I have, this is the blue obviously is water. In the two red boxes are the two zones we're going to put in our chart here. From about the surface to about 1,000 meters is what's called the photic zone. And that word probably sounds familiar, hopefully, to a word that you've learned before, photosynthesis. So This is the upper part of the ocean where photosynthesis is occurring. This is the light zone. So the upper part of the ocean that gets sunlight. This is where photosynthesis occurs. I always like to say that when you see a in front of a word, like an aphotic, a typically means not. So this would be the non-light zone. So these are the ocean depths with no light. So you can see that is basically everything else down to the bottom. There's no light. And we would call that the aphotic zone. The next slide is the distance from shore. So if you look at the top here in the red box, we have 3 zones. So up here, this top left, imagine in the diagram here is the beach. Okay, as you are walking out into the water, you're going to pass what's called the intertidal zone. This is the zone between high tide and low tide. So the one that's high tide, you would have water coming up further on the beach. Okay, that's when you would most likely see seaweed left behind. That's how you know where the high tide line was. And then low tide would be the lowest point that the water reaches. And then that area is called the intertidal. So it's the area between low and high tide. So organisms living here, you have to think about, in high tide, they're going to be underwater. In low tide, they're not going to be underwater. So these organisms are going to need to be adaptable to this changing time of having, being underwater and not being underwater. The next zone is the neritic zone. So if you can see that here, this is this brown chunk. So from the low tide to the edge of the continental shelf where it starts to drop off, that's the neritic zone. So the area from low tide to the edge of the continental shelf. And then the last zone here, you can see right here, is called the oceanic zone. And so basically this is all of the water. So from the continental shelf, the edge there, all the way out, the open water is called the oceanic zone. So it's the area beyond the continental shelf. All right, I'm going to stop there because I think I'm going to run out of time on this video, and I will start again with the last slide.